Introduction. Welcome to our channel. In today's video, we're diving deep into one of the most critical topics in the world of artificial intelligence and machine learning, building a scalable AI model deployment pipeline. Whether you're an AI enthusiast, a data scientist, or a software engineer, understanding how to deploy AI models efficiently is crucial for turning your theoretical work into practical applications. Today, we'll explore the entire lifecycle of an AI model, from development to deployment, focusing on best practices, tools, and strategies to ensure that your pipeline can scale effectively as your needs grow. So, let's get started. Section 1: Understanding AI Model Deployment. Before jumping into the nitty-gritty of building a deployment pipeline, let's clarify what model deployment actually means. Model deployment is the process of making your trained machine learning model available for use in production. This involves transitioning from a development environment, where data scientists and engineers can experiment and iterate on models, to a production environment, which is stable, reliable, and often requires real-time performance. The deployment process can be broken down into several key stages: development, versioning, testing, deployment, monitoring, and maintenance. Each of these stages is essential to ensure that your deployment pipeline is not only functional but also scalable. Section 2: Development Phase. The first phase of our pipeline is the development phase. This is where the magic begins. Data scientists typically work with historical data to train machine learning models using various algorithms. It's essential to choose the right model based on your problem type, whether it's a classification, regression, clustering, or recommendation task. During development, you'll want to focus on the following. 1. Data preparation. Data is the backbone of any AI model. You must gather, clean, and pre-process your data effectively. Consider using libraries like Pandas or Dask for data manipulation. 2. Feature engineering. This involves selecting the right set of features to improve model performance. Techniques like normalization, one-hot encoding, or feature selection can play a crucial role here. 3. Model selection and training. Experiment with different algorithms. Consider using frameworks like TensorFlow, PyTorch, or Scikit-learn for building and training your models. Don't forget to utilize cross-validation to assess your model's performance accurately. 4. Hyperparameter tuning. Fine-tuning hyperparameters can significantly improve your model's effectiveness. Tools like Optuna and HyperOpt can automate this process, making it easier to find the best parameters. 5. Documentation. Document your work. This includes detailing your thought process, the models you tried, the data pre-processing steps, and the results. Good documentation helps in the future, especially when iterating on your model or onboarding new team members. Section 3: Versioning. Once you have a robust model, it's time to discuss versioning. Version control is vital in any software development lifecycle, including AI. You'll want to keep track of not only the model but also the datasets and scripts used in training. Consider using tools like DVC, Data Version Control, or AMLflow. These tools enable you to track experiments, version datasets, and models seamlessly, allowing you to roll back to previous versions if needed. This is particularly important in collaborative environments, where team members may need to merge their work. Section 4: Testing Phase. Testing is a crucial step in the deployment pipeline. Validating your model's performance before deploying it to production can save you a lot of headaches later on. Here are some testing strategies to consider. 1. Unit testing. Test individual components of your code to ensure each part is functioning correctly. You might want to use tools like PyTest for Python. 2. Integration testing. After unit tests, check how different parts of your system interact. Make sure your model can ingest data and produce predictions without any issues. 3. Performance testing. Evaluate how well your model performs under load. You can use tools like Locust for load testing. It's essential to understand how your model will behave under real-world conditions. 4. A/B testing. When deploying your model, consider implementing A/B testing to compare it against a baseline model. This allows you to measure improvements in performance and user experience. Section 5: Deployment Strategies. Now that your model is tested and validated, it's time to deploy it. There are several strategies for deploying models, and the best choice will depend on your specific use case. 1. Batch deployment *. This involves processing and making predictions on large batches of data at scheduled intervals. It's a good option if real-time predictions aren't necessary. 2. Real-time deployment *. If your application requires instant predictions, you'll need to deploy your model as a web service. You can use frameworks like Flask or FastAPI to create APIs around your model. 3. Edge deployment * For applications that require low latency or operate in environments with limited connectivity, consider deploying models on edge devices. In such cases, TensorFlow Lite or ONNX can be beneficial. 4. Containerization *. Regardless of your deployment strategy, using containers can make your deployment more consistent and scalable. Docker allows you to package your model and its dependencies into a single container, which can run anywhere, from local machines to cloud servers. 5. Cloud platforms *. Consider deploying your model on cloud platforms like AWS, Google Cloud, or Azure. These platforms offer managed services that simplify deployment and scaling. Services like AWS SageMaker or Google AI Platform can help streamline the process. Section 6. Monitoring and maintenance. After deploying your model, monitoring its performance is crucial. This phase involves tracking various metrics to ensure your model is functioning correctly and providing accurate predictions. 1. Performance metrics *. Keep an eye on key performance indicators, KPIs, like accuracy, precision, recall, F1 score, and latency. Use tools like Prometheus and Grafana for real-time monitoring dashboards. 2. Data drift * Monitor for data drift, which occurs when the statistical properties of the input data change over time. Establish thresholds for acceptable variances and retrain your model if necessary. 3. Model retraining * Over time, your model may become outdated. Implement an automated retraining pipeline that triggers when significant data drift is detected or at regular intervals. This ensures that your model stays relevant and continues to perform well. 4. A feedback loop *. If your application can collect user feedback, utilize this information to continuously improve your model. This feedback can provide insights into areas where the model is underperforming. Section 7. Scalability considerations. Scalability is a crucial aspect of your deployment pipeline. As your user base grows, your model must be able to handle increased loads. Here are some strategies to ensure scalability. 1. Load balancing *. Distribute incoming requests across multiple instances of your model to prevent any single instance from becoming a bottleneck. Tools like Nginx or AWS Elastic Load Balancing can help with this. 2. Autoscaling *. Implement autoscaling features offered by cloud providers to adjust the number of active instances based on current demand. This ensures that you are only using resources when you need them. 3. Microservices architecture *. Consider breaking your application into microservices. Each service can be independently deployed, scaled, and managed, allowing for more agility and flexibility in your deployment pipeline. 4. Caching *. Use caching mechanisms like Redis to store frequently requested predictions. This reduces the load on your model and speeds up response times, especially for high-traffic applications. 5. Resource optimization *. Monitor the resource usage of your deployed models. Optimize your code and model to use less memory and processing power, which can help reduce costs. Section 8. Conclusion. In conclusion, building a scalable AI model deployment pipeline requires careful planning and execution. From the initial development phase to testing, deployment, monitoring, and maintenance, each step plays a vital role in ensuring that your model performs effectively in a production environment. By following best practices and leveraging modern tools and technologies, you can create a robust pipeline that not only meets your current needs but also scales effortlessly as your demands grow. Remember that the AI landscape is continuously evolving, and staying updated with the latest trends and technologies is vital for success. Thank you for watching. If you found this video helpful, please give it a thumbs up, subscribe to our channel, and share it with your fellow AI enthusiasts. If you have any questions or suggestions for future topics, leave them in the comments below. Until next time, keep building and innovating.